Hello, everyone. Can everyone hear me okay? Sounds good. I forgot my most important prop. So this is a talk primarily focused about trying to get people who do software interested in the world of hardware and how accessible the Internet of Things actually is in your day-to-day life. So for me, personally, I work at Square. If you can't tell by these great zooming background logos, you can find me on the internet if you want to. I'm pretty available. But if you're interested in the talk or the slides or stuff, there's a link at the end, so don't worry about taking pictures or whatever. Should be pretty easy. And then this talk is also a little bit of a story. So for me, a few months ago, there was a specter haunting my life. That specter was heartburn. I was fairly new to the whole concept of heartburn, and it was not a great experience. I tried Googling stuff. I tried figuring it out on my own, like, oh, greasy foods. Oh, you might have, spicy foods or alcohol. There could be all these things that cause heartburn. Who knows? Eventually, I couldn't figure it out, and I kind of gave up, and I decided to take it to a professional. Our interaction was a little less intimate than this, but we talked about it, and this question came up about, it sounds like you have heartburn. Do you say you have, would you call it occasional heartburn? Would you call it frequent heartburn? I was like, I have no idea. I don't write down every time I take heartburn medication. I don't, really have a good idea of, do I get heartburn on the weekends? Do I get heartburn in the weekdays? This is something I haven't really been paying attention to, but obviously now that I think about it, it could actually be pretty handy for understanding more about my medical condition here. And so being a developer and technologically minded, interested in getting my hands into all sorts of technology pies, I decided that it would actually be a lot better if I, developed some kind of plan of, maybe whenever I get heartburn, I eat a lot of Tums in my life nowadays. And so, I have this plan of heartburn, I take some Tums, and then that, magically gets recorded into a spreadsheet somewhere. I could just write that down on a piece of paper, but a lot of times, I'm taking some heartburn, it's in the middle of the night, I'm waking up and not really happy to log into my computer and log that down somewhere, or, it's dark, I can't write anything at night. So I kind of had this idea of, getting all of these individual heartburn events and logging them into a spreadsheet. And then, thinking that IoT could be a good option for this, I started figuring out what kind of technology I could use to solve this problem. I'm recently pretty heavy in JavaScript nowadays, and so I wanted to find something that would be pretty easy for me to work with in JavaScript. And what really came out there was the Tessel. Has anybody ever heard of the Tessel? Looks like about as many people as I expected. You can imagine it as similar to an Arduino or Raspberry Pi, if you've ever worked with some of those. It's actually quite similar to a Raspberry Pi in terms of it's an embedded Linux board. And so this is actually a device. I have mine stuck to my Tums box. It's not very big, and it's kind of a full-featured Linux computer that you can access only headlessly, but you can push JavaScript code to it and get it running. And so for me, it really met a lot of the requirements I was looking for. I wanted something that was fresh, something that's been updated in the last decade or so, especially in IoT. You want something that's been actively worked on in the last few weeks, few months, something you can rely on. I wanted something that had Wi-Fi. Obviously, the Internet of Things is kind of defunct if you can't connect it to something else, especially Google Spreadsheets, which was my goal. And so I don't have a lot of LAN cables running around my house. So it had Wi-Fi, which is good. And then most importantly, it had this great JavaScript support. So it was really meeting all my boxes. I logged on to SparkFun, bought one. If you've ever used SparkFun before, I highly recommend it as your outlet for beginner IoT and hardware projects. It has a lot of great tutorials and resources in addition to the marketplace. I've actually been out to their office in Boulder. It's super cool. And so I get my Tessel a few days later. I plug it into my computer, and then I start going through the instructions. Actually, this is where I'm actually incredibly surprised at how easy it is. if you've ever used Raspberry Pi, you know that just starting up a headless Linux computer can be sort of complicated if you don't have all the things plugged into it and all the files set up. And so all I had to do is open up my command prompt, npm install this global package. And so this is the CLI controller for the Tessel. You can tell it's kind of version 2, T2. So I install this package, and then it gives me access to this T2 command that I can use wherever. And so this is already getting pretty easy, because then I can just list all the Tessel devices connected to my computer. And since mine's plugged in, it searches for a second, finds the one that I have plugged in. And I was like, oh, actually, this isn't too bad. It looks like I'm already kind of up and running. And from there, setting up things like Wi-Fi is pretty simple. You just pick out your username and password there, and then your Tessel is online. And then you can actually, you do this provision command, and that sets up a SSH key pair for your computer and your Tessel. And so then you can actually program your Tessel over Wi-Fi. So you can then unplug it and program it over the air if you want, or you can keep doing it USB. And so this provision command kind of registers your Tessel to your computer and makes it a little bit easier for future updates. And so then, now that I have it set up, generally speaking, with my computer, I wanted to actually see how I could get it to work. This was another area that was pretty easy and familiar with someone who is in this JavaScript ecosystem. And so I created a new project folder, hop in there, and then I use this t2 init command. If you're familiar with yarn init or npm init, it does pretty much the exact same thing. It creates a package.json file. It created a index entry point, and then has a couple other options there for your npm configuration, and as well as a Tessel configuration file as well. And then I pop open that index file, look at the code. Actually gives you an example app right there with it. And so using Tessel. You want to speak a little bit louder? Oh, sure. Maybe my microphone could be better positioned. Is this better? I can try yelling more. So the Tessel code works kind of how you expect. It's an npm package already included in your initted directory. And then that package has access to kind of the whole array of the hardware API. For this example, you can see that it turns an LED on, the second LED, or maybe the third, depending on your index scheme. And then it has an interval function of just turning the intervals on and off. And that's exactly what it did. And so to get this code from my local machine onto the Tessel, all I had to do is this t2 run command. So this is actually paired with a t2 push command. And so these are actually pretty much the same thing, but they work slightly differently. t2 run will put your code onto the Tessel in memory, so it only runs in the RAM. And then that Linux computer on the Tessel will run the code only from RAM. The push command does the more sustainable version of taking that file, putting it onto the Tessel with all the included npm packages and everything you need. So it puts it in memory. So if you detether from your computer or from your Wi-Fi environment, it can actually run totally headless there as well. And so you see, pushes over a pretty small amount of code, nothing much going on there. And then, my Tessel starts flashing. And so kind of out of the box, this is pretty safe, pretty harmless, nothing too scary going on yet. But obviously, flashing lights is kind of short to my IoT healthcare goals. And so I want to figure out how to get this Tessel code to interact with Google Sheets. Luckily, Google really helps you out there with a lot of APIs. If you've ever used a Google product, I imagine you've noticed that they have pretty much an API for everything. Some of them are only APIs. So this was really handy. Unfortunately, in order to use these APIs, you have to authenticate. And there's a lot of different authentication schemes. Some of them are more standard, so it uses OAuth. And so it has the traditional, like, you redirect, you get a login, you get a code, you exchange that code for a token. Server applications or installed applications kind of have this easy flow that makes sense. Client-side applications are supported, but a little bit different flow. But obviously, my totally headless IoT project. It's not a client-side web application. It's not really a server-side web application either. There is an OAuth flow that is called the Applications on Limited Input Devices flow. And so this is the one that was for me. You can see it's kind of complicated because you have to make a web request, get that code back, and then you have to give that URL to the user to then go on a different device to get that code back that is turned into your authentication code. And so this was a little bit trickier for me, but essentially what I ended up implementing was the Tesla would make these requests, the code for the Tesla would make these requests. I would authenticate my device while I was plugged into my computer. So I'd run the code while I was on my computer, tethered, and then I'd get my access token that I'd store in a credential file, and then I would just paste all those credentials over to my Tesla when I pushed my code, and then I was able to make authenticator requests while also having implemented this rather cumbersome OAuth strategy. But it's kind of required when you don't have a screen or any input or a browser on the device that you want to make requests from. So that wasn't too tricky, but it was definitely a learning experience. And then from using the APIs is actually pretty simple. Anybody who's familiar with the Node package, you can see that you just require this previously installed package. There's a lot of different subsets of APIs included in the package, and so I'm using the Sheets aspect. You identify what spreadsheet you want to update. So this was a new spreadsheet I made that was just a empty spreadsheet. You can pick where you want to put the input, and then I do an append operation to get that information into the spreadsheet. So nothing too complicated there. The user-entered thing is kind of interesting because if you ever use Google Sheets, that sometimes it'll automatically format your dates or things like that. That's an optional thing. So user input applies that sort of range of automatic formatting and or input adjustments, whereas you can just input raw data instead if you want. And so then the next part of this equation, now that I'm able to update my spreadsheet effectively from my Tesla, is to figure out how to monitor whenever I'm taking a Tums in the middle of the night. And so this is a pretty simple circuit diagram of what's going on. And I'm using a different aspect of the hardware library that's using interrupts. And so for those of you who aren't familiar with the world of dev boards and hardware, interrupts are basically, you can imagine them as event handlers from the world of JavaScript. And so whenever a specified pin, which is a port inside my dev board connected to some wires, whenever that voltage goes up, when it rises, this is an event handler for that action. And so it runs my Google Cloud or my Google Sheets updating function whenever a pin rises up. And so then I just have my button set up to whenever I press the button, the voltage on that pin will go up, and then my function gets run on the Tesla. And so that turns into my device here. You can see I really worked a lot on the presentation and packaging. Yeah, I basically just have, you can see kind of, it's a little dark, but there's a button kind of stuck on the side here. And so whenever I opened a Tums, I would just smash this button, and my Google Sheets would be updated. Luckily, I have an outlet kind of close to my counter on my bathroom, and so I just kept it plugged in most of the time for power. But you could also plug it by any kind of USB battery if you wanted to. There's a lot of options there in terms of power management. And so that was actually a pretty decent experience. I'd open a Tums, I'd hit the button. If I ever made a mistake and hit the button too much, I'd just go into the spreadsheet and glance out those rows. So that wasn't too tricky. At the end, my spreadsheet kind of looks something like this. And then I was able to have a little bit better of a conversation with my doctor about is this occasional heartburn? Is this frequent heartburn? Do I have a good idea of, am I going to die next week? I have no idea. Still good. I'm on a great treatment plan now. But a couple things to keep in mind about the Tesla and how it works. These Tesla include files that was created with that T2 init. That's actually similar to npm include or git ignore, git include, those kind of files that specify when you're copying files from your computer over to the Tesla, what gets included or what gets ignored there. And so by default, the Tesla will do kind of a generic form of tree shaking to find all the code that's required in your directory to put into the Tesla to kind of bundle it up as small as possible. But for me, I had these access tokens and credentials that I was copying over as well, and it's stored in JSON files. And so I had to make sure I included those in the specifications as well. And then another option that's pretty easy as well is if you just want to copy everything in directory instead of kind of avoid that tree shaking process, or if you want to try to debug, maybe you're missing some files, you can just run it with these full commands that'll copy the entire directory over, which is a little bit more convenient, but at the high expense of time. And so if you're copying, 45 megabytes of NPM packages over a USB wire, that could take 30 minutes. So something to keep in mind, and another advocate for the flashing over the wire aspect. That's really handy as well. And so to give you guys some external resources about what might be interesting, this is the Tesla documentation, Google Sheets documentation. There's also a really good tutorial that SparkFun did that I used a little bit for inspiration. They use the service If This Then That. Has anybody heard of that? Yeah, so it's kind of like you can imagine it similar to Zapier or some of these other integrators, but it connects a lot of different projects together. And so they made URL requests to IFT, and then IFT would update the Google Sheets, so they didn't have to deal with all that authentication on their Tesla, which was maybe a better idea in hindsight. And then, if you are interested in this kind of thing, I would actually recommend, there's a lot of tools out there besides the Tesla, because the Tesla was like $40 or so when I bought it, and a Raspberry Pi Zero is $5. And so there's a big difference there in price, and the Raspberry Pi also gives you options, a lot of accessibility options in terms of just running a computer, a Linux board from there, or if you want to do something similar to, there's the same packages that run the hardware in Node, but Python and C#, everything you need there as well. And then there's a couple other options if you're looking to really cut your costs and maybe make some actual IoT devices. There's this little tool called Espruino, which is a more JavaScript-oriented expansion of a couple boards, and the ESP826. So these are actually system-on-a-chips. They're really small. They cost very cheap, and you can program them. It's a little more complicated, similar to programming Arduinos without as good of an ecosystem, but they are very cheap. And if you're actually making something like the Amazon Dash button or an actual IoT button, this is very similar to what you'd actually be using in a production hardware line. So there's definitely other options out there. Raspberry Pi has such a good ecosystem that I'd probably recommend that. But I wanted to try out the Tesla because it had that great JavaScript ecosystem as well. And I actually have some time for questions, but this is a link that you can find my email address. You can find the slides for this talk, as well as other talks I've done. And there's also a Google form there. So my company, as part of sponsoring me to come out here, not only makes me pander for them, but also will give out swag if you want to take a try with our APIs. So fill out the form. You can get some T-shirts or ball caps or whatever I find in the swag closet. But yeah, I hope you have enjoyed this talk, and please give me some feedback, and I'm open for questions.
We got time for a few questions.
If you don't have any, that's good too. But I wish I had some good jokes like the Tommy. Well, cool. Thanks a lot.